Righty, so what we're doing now is we're just taking them skills from that 5, but we're extending them slightly. So you can see the question looks extremely similar, but the difference is that we have sine 2x this time. Okay, so we need to take that into consideration when we're working with this. So we're going to start off really thinking about, well, I'm going to rearrange it. Take the 1 over, divide by 2. Right, we have that. So the issue is, the difference is that we have sine 2x. Now, if you look at your boundary here, we're only looking at x. So what I like to do is I like to think, right, well, actually, we're not dealing with x this time, we're dealing with 2x. So, probably change that a bit because that will always be a 0. Instead of x, you've got 2x, so what we need to do is times both sides by 2. So 0 times 2 is obviously still 0, but that is 720. Now, this tells us how many values we are willing to get. We're willing to get how many values we're going to get. Okay, because that's what we're looking at, up to 720. Now, that's the key difference, right? The rest of it is the exact same as what you did before. We're working in degrees this time. Positive sign there and there. See the running theme of the exact values here. Okay, so this time 2x is, so we have 30 and 180 minus, which is 150. Now, we are not done. We need to be drawn ourselves to this. Okay, so 2x is between 0 and 720. But we have 30 and 150. That means there's many more values that we can look at. So we need to add on 360 because there's higher values. So that's going to give us 390, 510. 360 would be too many. So what I like to do, don't know why I just do it, is I like to write them all in a row. Now your aim, remember, when you solve was always to get x, so we're not finished. So then our final step is to divide all these by 2. And those are our answers. Always check that your answers are between your original starting point, which was 0 and 360. But the key is your boundary has changed. You're not dealing with x, you're dealing with 2x. So we need to change that. I like to put a box around it because there's more values. Okay, there's more values to be found because obviously you're looking at, because it's 2x, you're looking at double the amount of waves. That's why there's 4 values and not 2. Okay, same with this one here. So rearrange it. Again, we have a 2x, so let's change this over here. So times both of them by 2. Same as last time. We've got cos this time, it's positive, so there and there. We are working in radians as well, so we need to take that into consideration, but we'll deal with that in a wee second. So what we're going to have, so theta cos to the minus 1 of 1 over root 2, which is your 45. So 2x is 45, and 360 minus 45, which is 315. Now at this point, I'm going to put it into radians. Okay, so that's pi over 4, 315, again working with it. Okay, so it's up to you how you want to do it. You can either work out either 315 over 180 and simplify it down. Thinking about what they both divide by to get you all the way down. I mean, you can do it in stages, obviously. So divide them both by 5 is going to give you 63 over 70, not 72, 36. Which is going to give you 7 over 4. Okay, or think about 45 times what is 315, and again work it out that way. So it's 7. And then I'm going to divide that by 2. Now you can see that we're working in radians. Okay, 315, I didn't add on 360 this time because I knew we didn't need to. Okay, you need to check. I'll make that a bit neater. So you always check, okay, if you need to add or subtract 360, but in some cases you don't. Okay, so it doesn't always happen, but always check. You need to add to 360. 2 pi is 360 degrees. But in some cases you won't need to add on. You just always need to check though. But in this case, there is only 2 answers.